Dear students, Assalamu alaikum. Today we are going to discuss the topics of chapter 3 of ninth physics, that is coefficient of friction and graphical interpretation of friction. What is mean by coefficient of friction? We know that the magnitude of, first of all, that the magnitude of maximum static friction is directly proportional to the normal force, directly proportional to the normal force. So mathematically we can write it is that the static frictional force, the maximum static frictional force, is directly proportional to that of the normal force. So now putting constant of proportionality, so if maximum is equals to mu s if n, so dividing both side by, so mu s will be equals to if is maximum, that maximum static frictional force divided by normal force, which is the expression for the coefficient of static friction. For the coefficient of static friction, it is basically the ratio of the maximum static frictional force divided by the normal force, and the value that the mu s is proportionally constant. Now this it's the coefficient of static friction and depends upon the nature of those surfaces and contact before sliding. So it's the expression of coefficient of static friction, that it's the ratio of the maximum static frictional force to the normal force. The second one, we are going to derive the expression for the coefficient of kinetic friction, that the mathematically we know that the kinetic frictional force is directly proportional to the normal force, So now here putting constant of proportionality, that is if k equals to mu k f n. So mu k can be represented as kinetic frictional force divided by normal force. It is basically the ratio of kinetic frictional force to the normal force, which is the required expression for the coefficient of kinetic friction. Now the second topic is graphical interpretation of friction. Graphical interpretation of friction can be basically explained with the given graph, that and the beginning, that it's a graph between the applied force and the static and kinetic frictional forces. It's a graph of applied force versus the kinetic and static frictional forces. The graph shows that with the passage of time, when the applied force is increased, the static force also increases. That it's a linear graph. Up to this value. So it's up to this value. It represents that when the applied force increases, the static frictional force also increases. But at a certain point, when the static frictional force achieve its maximum value, then at that point, the frictional force is called limiting friction. The frictional forces between these two surfaces, when both of them are stationary, then this value is called limiting friction. At this point, the static frictional force became maximum, and after that, the frictional force, when the applied force increases, then at this point, when the applied force overcomes the static frictional force, then at this point the object starts moving and frictional force rapidly decreases to a smaller kinetic frictional force value, and after that it remains constant, So this region up to this maximum value or limiting fraction, this region is called static region, and after that the object starts moving. So in that case, when the object is moving, then the frictional forces between both of these objects will be the kinetic force. So this region is called kinetic region, and when the object is stationary, so this region is called static region. Dear students, if you are facing any kind of difficulty in such topic, then your response will be highly appreciated. Thanks for watching.